Now let me show you how to do a DC analysis of your circuit. A DC analysis will determine the voltage at each of every node in the circuit at time t equals 0 and the currents through the various components. The voltage values are measured relative to a reference node called the ground node, and all the calculations that the computer will do are based on the voltage current characteristics of the components and Kirchhoff's laws. So let's go over here and look at the diagram we entered in the circuit sandbox earlier. And what I like to do now is to perform a DC analysis. I'm going to come and click on the DC analysis tool, like so. I got an error message. It says, please make at least one connection to ground. In other words, I've forgotten to indicate which one of these nodes is the reference node. So to do so, I'm going to come over here and drag a ground connection and attach it to the bottom node of my circuit. So that's now the reference node. Now when I ask for a DC analysis, all the components and all the current probes are labeled with the currents flowing through the circuit at that point, and all the nodes are labeled with their relative voltages. So the battery, as we might expect, modeled by a 1-volt voltage source, has 1 volt at its positive terminal because the negative terminal is hooked to the ground node, which, as we can see, has a value of 0 volts. With this particular resistor network, we'd expect a 1/4 volt at the intermediate node in the resistor network, and in fact that's what we see. This node does have a 1/4 volt. If we look at the currents, we discover that we have 250 microamps flowing out of the battery, and that's split evenly, 125 microamps each, going into each of the 2 bottom resistors. We also noticed that the voltage source itself has been labeled with the current that's flowing into or out of it. Notice the reference voltage for this measurement is pointing into the device, so current flowing out of the voltage source has a negative sign. Okay, so we've done the complete DC analysis of this circuit. If I click, the annotations go away. Just for interest, let's see what happens if I move the reference node here to be the intermediate node of the voltage divider of the resistor network. So now when I click for DC analysis, you can see that in this particular case that I have a total of 1 volt across the voltage source is what I expect, but all the relative values of the voltages have now changed to be with respect to that intermediate node. So you can see everything's a 1/4 of a volt lower. The other thing that we notice is that the currents have remained the same, which is what we'd expect. So that's DC analysis, a handy tool to make sure that you've selected the right values for your components, at least in the static case.